Hello, hello. Bread God, hey, it's been a minute. Have we been well? Spetry, congrats on the first. Crim, hey. Hope everyone is doing well today. I feel like I'm forgetting to do something, but I think it's just because, like, I don't think I've just done a normal math stream in a minute. I've been doing so many other reading groups or collaborations and stuff that I've gotten not used to just doing normal math. You're good, Bread God. Since we get a question, my plan for today was to look into complex analysis. Actually, what's going on with the top first? That people need to know. Oh my god, Spectre, you are pulling away with it. Actually, wait, no. You're back under double. Never mind. The gap is closing. Or maybe. Jed must have gotten some first. Because you were double Jed. But I think not anymore. Wait, what was I doing? I didn't want to hide that yet. So yeah, my plan was to just do some complex analysis studying in the downtime. I read through section 2.3 yesterday, and it's kind of terrible with how the authors are writing this. It's a whole lot of clearlys and obviouslies and very little actual explanation. And so I want to work through some of the stuff that they're doing. Starting here, but like kind of throughout a couple more things. So we have the function z minus a, z minus b. Well, yeah, but you got to redeem the first thing if you want to have that recorded for history's sake. And so the book begins by taking, just to show that a is a branch point, take z equal to a plus just a little bit. So some very small radius epsilon 1 times some angle e to the I theta 1. And so let's see how W changes, or how W looks with this. You know what? I want 1/2. So this bit becomes epsilon 1 e to the I theta 1. And this bit becomes a minus b plus epsilon 1 e to the I theta 1 to the 1/2. The one for first has been around for forever. The first redeem, it does go away once someone claims it, so you won't see it right now. Bam, bam, bam. Slim, thank you so much for the raid. I saw you were doing some GeoGebra type stuff, and then something else too. Hope it went well. You know, actually, it reminded me of something, and I forgot to bring it up because I got distracted. But it reminded me of Euclidia. Ah! Which is it almost reminds me of like the natural numbers game, but with geometry. Where it kind of gamifies constructing geometry stuff from like first principles, and you get like more points if you do it with fewer actions. Did GeoGebra did test for autism? Oh yeah, I saw that too, right? But people say after someone sneezes. That's a cool little like insight into culture, I think. Oh nice, bread god. Yeah, I did a couple of these on stream. Geometry, or at least this type of geometry, isn't really my favorite thing. So I didn't do a lot of it, but it's pretty cool. Yeah, until we get a question from someone in chat, my plan was to try to learn more about branch points because I'm still pretty weak on them, and so and the book's explanation of them is pretty terrible. And so I want to investigate the branch points of this square root function, but with two different things going on. So I'm kind of following along with the book's explanation, trying to actually write out what's happening. Because the book explains very little and prefers, they more prefer just to attach the word clearly onto everything and not actually explain anything. And I have not found it very helpful. So one thing they never explained is once you do this substitution, they never explain what happens to this term. Now, they start to talk about estimations, and so I think they're just getting rid of something that's second order in epsilon 1 because it is a very small number. And so I think from here, they start to say about a minus b to the 1/2 epsilon 1 to the 1/2 e to the I theta 1 over 2. You know, it's kind of weird how I put the 2 here, but I put the 1/2 there. I never quite know where to put i's and constants and variables. Hey, Mer Shawan. Okay, and so now with this estimate, I want to figure out what happens if you let theta 1 vary from 0 to 2 pi. Basically what we're doing, let's just say the point A is right there. We're just letting z, our variable, do a small circuit around that point A and observing how that small circuit changes under this mapping. Actually, you know what? I was gonna actually do like a table of values and plug things in. But I feel like it's actually decently clear, which now I'm pulling a thing I was just ranting against. Oops. If theta 1 equals 0, then W1 is a boot. I didn't give myself enough room. A minus b to the 1/2, epsilon 1 to the 1/2. But if theta 2 equals 2 pi, W is a boot. This becomes an e to the I pi, Zach's evil twin, which is a -1. Hey Phobos, I hope you're well. 90-degree angle is the letter L. The economic depression had kids having club penguin fur balls. And that's the reason why those creatures called the boo-boos that you see in... What? I feel like you randomly generated like 4 words and had to make a sentence using all 4 of those words. I have no clue what that means. Okay, so this helps me realize that this situation isn't so different from just z to the 1/2, where under this mapping the unit circle maps to a half circle. And then when you have this situation, if you go around just one of your branch points, you still get this half circle thing going on, I think. Is that right? I think so. Hey, Fembucks. It's also your grandma's birthday. Oh, nice. Happy birthday to your grandma. Okay, so that's the first thing that I wanted to learn about branch cuts with this function. But the next thing I want to know is, how does the choice of range for your angles determine the nature of the branch cut? So z minus b is equal to r1 e to the I theta 1. Z minus a is equal to r2 e to the I theta 2. And so this is where things are getting weird for me. Oh, nice, Bread God. Well, good luck. It's definitely not easy. Um, it's potentially misleading to make like one negative one. I don't know if it really is potentially misleading. I'm just gonna say they're both positive, which is potentially equally as misleading. But sue me. They put A on the left or B on the left? They put A on the left. And so they say if we're measuring theta 1 and theta 2 between 0 and 2 pi, that corresponds with this branch cut here. And I'd like to know why. Where do they put the origin? They don't put the origin anywhere. Which I guess it doesn't matter because we're doing these local polar coordinates. So if I choose a point right here, let's just say that's length 1, angle pi over 4 from B. How does A measure this point? We need this angle and that length. It was Kazakh. May Tengri give me 500 horses. That's a hell of a thing to wish for. Like, that's a lot of horses to manage. It's a lot of poop to clean up. What do I know about this triangle? Don't I need one more piece of information? I shouldn't. I was going to just use law of cosines or something on this. It's not really coming to me, though. Maybe I should just make these numbers... I should just attach numbers to this. To make these calculations a little bit smoother. Kindness is a language which the deaf can hear and the blind can read. Mark Twain? I feel like a Mark Twain quote in a fortune cookie is kind of weird. Hey, Adia. Kindness is a language which the deaf can hear and the blind can read. Feels like a crappy quote to me, I'm gonna be honest. I don't know. Maybe I'm too judgmental. Also, this is really like the thick marker. What's the thin one? That's kind of a difference. Not a big one, though. It might have to do with the pressure as well. Yeah, if I press down harder, it's a little thicker. Okay, where was I with this? Okay, can I figure this out without resorting to making A and B actual numbers? I'd like to keep it general if I can. Let's have a triangle. That's one. Ugh, I don't give myself enough room to actually do anything. One, Pi minus pi over 4 is 3 pi over 4. I want to find this length in this angle. We need that this length down here is b minus a, and then we have enough to solve the triangle. Why does my eraser feel so big? Whoa. Oh. Huh. Tiny eraser. Medium eraser. Big eraser. Okay, sorry, I'm going to stop playing with it. So law of cosines can get us the remaining side. This is a lot of... It's probably more work than they're intending to be done here, but I just want to do it. It's a good clip. Nope. B squared minus 2ab plus a squared. Hey, Adnan. Cosine 3 pi over 4, negative root 2 over 2. So we're going to get plus root 2b minus root 2a. That's terrible. I'm from America. I should probably keep things in terms of b minus a. Nice. Welcome in, Adnan. Does this factor, just out of curiosity? I feel like it does. No, I don't think it does. Does it? No. Do I have a... Are you just going to play 20 questions with me here? I'm just trying to do math. Adnan. You really love physics and want to self-study physics and math. I'm an undergrad engineering student. I'm comfortable with JE level physics. How should I self-study? So like the way that I self-study is I just get a textbook that seems interesting and read through and try to engage with it. That's not perfect though, because when questions pop up, there's no one to answer them unless you get lucky with a Google search. What's a step up from that is MIT OpenCourseWare. So if you're interested in a particular like type of thing, just try and find a course on here, and they usually have or like that all these have like YouTube lectures of actual like MIT professors teaching their classes, and so that can help out a lot too. So like I've done the linear algebra uh open courseware thing through here, and it's pretty good with string. So hey Ek, hope you're doing well. String lecture on linear algebra are 5-star. There are a couple bits that I wasn't a big fan of, but overall I really liked them. I assume that you've watched them too. Like in terms of like being out there for free on YouTube, it's really amazing that something that in depth is just like out there long while back. Oh, nice, nice. Yeah, I did it at like the start of the year. I thought it was very interesting that like he doesn't talk about linear transformations until the very end. It's kind of an like an odd approach to linear algebra, but I assume he has a reason for it. I haven't quite been able to like figure out why he would avoid it. The null space and row space things last couple lectures were fun. Oh, actually, there are like two different versions of lectures as well. I think I watched the older ones. This for what I remember, like that was like his emphasis from the start. I wonder if he changed it actually for the more recent ones, but he talked about like the four like fundamental subspaces, like row space, column space, null space, left null space, and how those kind of make up the foundation of a lot of linear algebra. Yeah, a custom emote. Through Twitch, you have to be an affiliate, and you upload it to your channel. But there's like browser extensions like Frankerface, BTTV, and 7TV. What course of maths will you suggest for studying on cosmology? Ooh, I haven't studied cosmology, so I'm not sure exactly. I would love to study it someday. Uh, what is good for cosmology? I'm thinking like calculus and differential equations is good for the physics of like planet orbits and stuff like that. But I'm thinking there's also like you need to learn about like light and like redshift and blue shift and stuff like that, and I don't know what bucket that would fall under. Besides just like maybe like waves in physics or something like that. I would probably just try and look up like cosmology courses. Optics, yeah. That's a better term. So yeah, I don't know offhand, but I'll probably just try and look up cosmology degrees from universities and seeing what they require students to take. You can carry one a lot of distance. Yeah, it's really fundamental to a lot of things. What am I solving? This is just a little like self-study thing. I'm basically trying to learn about the branch points for this complex function. Am I on LinkedIn? I do have an account, but I don't like put it out there publicly. And so I'm trying to learn why if we define local polar coordinates around A and B, the choice of how we measure theta is what determines how the branch cut looks, and I'm trying to figure out why. And I think I'm maybe being a little bit too extra with this geometry. Zach, a branch cut? Mm-hmm. I mean, I have like a Twitter that I don't really use, but it is like a Don Factorial Twitter. Other than that, it's really just Discord. Um, so maybe the more important thing is that if this angle is pi over 4, this blue angle over here is definitely less than pi over 4. And so the book found that the book basically kind of made these zones for, well, actually we should do, I should have done this earlier. If we're defining these local polar coordinates, then our function w can also be expressed as root r1 r2 times e to the theta 1 plus theta 2 over 2. Kind of funny that there's an arithmetic mean and a geometric mean. And so the book defined capital theta. I don't know how, like, it's going to look the same as my lowercase theta. That's way too big. As theta 1 plus theta 2 over 2. And so the book made different zones for big theta. Yeah, I mean, it's specifically with like a square root, I guess. I don't know if there's anything actually to that, but I'm looking at, this is my original like function that I'm like dealing with. So in this zone over here, so they just kind of said this entire zone is big theta equals 0. But that doesn't, like, I don't know what that means necessarily. Like, it certainly doesn't equal 0 everywhere. It only equals 0, in fact, right there. So that's what I'm trying to grapple with as well. And what I'm trying to reconstruct right now is this kind of chart they made here to demonstrate why this branch cut exists here. The smallest worm will turn being trodden on. I don't know what that means. Most of the fortunes that that thing has given me so far have been pretty crappy, but it's kind of fun to laugh at them. The smallest worm will turn being trodden on. I feel like any worm, if you trod on it, is going to do something. But yeah, no, those fortunes come from a random list I found on on Google of like 2,000 of them. And also, a Shakespeare quote doesn't belong in a fortune cookie either, I don't think. Like, do I know Johnny Sins? I do know him. He's a man of many professions. Um, so what's up? Like, I don't know that person, no. So, and so here's the thing. So they say over here, this is where capital theta is pi over 2. But there is, there is a point, like, you know, maybe somewhere there. Oh, wait, it's divided by 2. So wait, if I take a point right here, angle B is pi over 2. Angle A, it could approach pi over 2 if we made A really close to B. Oh, that's okay. That makes more sense, because then big theta has division by 2. So in like the worst case scenario where A is like right next to B, it's basically pi over 2 plus pi over 2, which is pi, but then divided by 2. So I understand now why this thing here basically ranges from 0 to pi over 2 with respect to big theta. And I'm like, why are you talking about this? Say yes or no. If you're gonna be demanding like that, you can go away. Okay, so then let's do the same thing for this little box here. So we know the minimum here is pi over 2 if we choose a point over here. What happens if we choose a point here now? A is pi over 2, and actually by the same argument, B is approaching pi over 2. Hey, Zappin. So then what happens if I choose a point in the middle? Like I could choose it, I could find a point so that both angles are pi over 4, right? It'd just be like the midpoint, and then you can figure out what height you gotta be. So if they're both pi over 4, you get... Okay, so yeah, I guess it kind of like, in this zone, I imagine a graph of big theta, I guess. In this zone, like, big theta would start at pi over 2, dip down, and come back up to pi over 2, I guess. Is this introduced in a complex variables undergrad class? Oh wait, no, I'm wrong about this. I need to fix this. Yeah, it is. Right now I'm thinking about branch cuts, and that's a pretty important topic that you encounter pretty early on in complex variables. I got mixed up. If I choose a point here, angle A is pi over 2, but angle B is being measured like that. So if I want to maximize this angle, I would put B very far away, and it will be approaching pi. So it's like we would have pi plus pi over 2, which is 3 pi over 2 over 2. Gonna watch a bit on it? All right, sounds good. So this is going to start at 3 pi over 4, I think. What'll it be if it's right here? Yeah, I'm following along that exact section. So yesterday on my off day, I read through all of 2.3, and the number of clearlies and skipped over steps in this is too damn high, because I really didn't get it. And so I'm trying to slowly work my way through just this beginning part. And the thing I really want to know is why, like, how does this choice of theta 1 and theta 2 actually fix this particular branch cut? And so right now I'm trying to reconstruct this chart they have here and understand what they're actually saying, because as written, it makes very little sense to me. Like, big theta is certainly not 0 everywhere in this zone. I wonder if I should maybe reorganize it so that big theta, it's more like it on that line. It's 0. On that line, at best it's pi over 2. But that's only if A is really close to B, to be honest. Oops, I'm sorry, I didn't show my journal. What I just did is I shifted the big theta equals 0 from just like floating in the middle here to be like right on that line. Putnam? No, I don't like Putnam problems. Um. Hmm. No, I actually, the more I think about it, the more I don't get what this chart is saying. Even if I do this, I don't really know that that's true. Okay, maybe, Because it kind of depends where A and B are. Well, does it? I don't know. Maybe I should think about it in cases where if A is really close to B, that's the case where we can immediately get big theta's pi over 2 right here. But if A is really far from B, then where do we get pi over 2? I assume it's going to be on this line, but I'm trying to justify why. Like, maybe that's what this is trying to say. But the issue is that if B is really far away, then I guess it's kind of the work that I just deleted, where the angle measured from B is approaching pi. The angle measured from A is always pi over 2. But that's not pi over 2, that's 3 pi over 4. I guess that's overshooting it. But that doesn't mean it... Like, pi over 2 must happen, like, somewhere in this interval here, I guess. I guess we're just kind of forgetting about that little bit there. What's the soonest we can get a total angle of pi? Is it always right here? Or is there another place we can get a total angle of pi? I think it's just always right there. Then I assume, I guess the argument for 3 pi over 2 is going to be the same as with pi over 2. And then from 3 pi over 2, it's gonna... We're only ever gonna hit 2 pi right on this axis. But that's when the branch cut kicks in, because we're dividing by 2. And so... where we expect... to get... Like, where we started was just root R1, R2, because big theta was 0. But what we're getting, because big theta is 2 pi, is negative root R1, R2. But it's weird, because if I were to draw this contour, I think that's fine. It's going to map to a similar shaped contour that's still, like, closed in the image, is it not? Maybe it won't. No, it won't. Okay. Soon I thought it would. What happens if we wanted to use a contour like this then? But, well, no, I feel like it should. Wait. If we're approaching this point from below, that means W is equal to root R1, R2. That doesn't matter. E to the I 2 pi plus 2 pi over 2. So actually, that does get us back to 2 pi. So that contour is okay. Or physics numericals? I don't really know what that means, delete gaming. Like, I guess just post your question. I can tell you, yes, I can do it, or no, I can't. Okay, so my next question, so this contour is apparently fine. Why is this contour not fine? Um, so I guess let's think about this. We're starting at root R1, R2. Once we get to the opposite side, we're getting B is positive pi, A is 0. And so we're getting an angle of pi over 2, which means we're getting I root R1, R2. Okay. But now what? I guess, should I plug in? Well, I don't know what the angle at that point there makes easily. But I guess as we, okay, no, the important thing is as we come back around, well, okay, as we come up here, the angle from A is varying from 0 back down to 0. That's the thing to think about. And then as we come from here, the angle measured from A varies from 2 pi back to 2 pi. Is that why? Oh, okay. So A is 2 pi. The angle measured from B Isn't that also going towards 2 pi? So, okay, I guess what I've just noticed here is that there's like a discontinuity once we cross this branch cut and how A is being measured. Maybe the issue is actually, it's not how we approach this point. Maybe the issue is actually how we approach this point here from above or below. That's probably the thing to think about. So maybe W2 from above is that, but W2 from below. B is coming at it. B is approaching pi, whereas A is approaching 2 pi. And so we're getting an angle of 3 pi over 2, which is minus I root R1, R2. Okay. That's the branch cut issue. Oh my god, why couldn't they have just said that? It's because of how we're... Okay, well, they did say that, but just not clearly. Like, choose any point on this branch cut, basically. Well, you have to... It's not a choosing point. You have to choose a circle that circles only one of the branch points. And then look where that circle intersects the cut and approach it from above and from below, and that's your discontinuity. Okay. Oh my god. That's easier than I thought, but I'm glad I worked through that. The moment of inertia of a uniform cylinder of length and radius r about its perpendicular bisector is I. What is the ratio I over r such that the moment of inertia is minimum? Uh... 1 minute. Let me get that question on the screen. I think I can do that. I just remember how moment of inertia works. Hey, collar cone. Do I not have for a cylinder? Bruh. I bet you could, like, take the moment of inertia for a disk around the center and just multiply another dimension of length in there. Well, that doesn't make... maybe not. Delete gaming, are you just like given the moment of inertia for a cylinder, or do they expect you to find it? Oh, it's just a half mr squared? Why does the length drop out? I wouldn't have expected that. It's the same as a ring or a disc around the center. That's kind of weird. If we're just allowed to use that though, and let me know if you would have to derive that. And I can figure that out too, but oh, perpendicular. Wait, perpendicular bisector. I'm looking at parallel, aren't I? The perpendicular bisector. Okay, I guess it's with that axis. I thought it meant this axis in green, but now that I reread it, I think I was wrong. So this side is claiming for the perpendicular case that it's 1/12 m h squared plus 3r squared. So I'm just going to use that unless you tell me otherwise. I probably could figure out how to get that. But here, both the height, or both the length and the radius are capital R. So I'm gonna edit what I just wrote here. So we get 4/12 is 1/3. Okay. And so they're asking us to find the ratio I over R such that the moment of inertia is minimum. Or the ratio L over R? Oh, did you leave off the L in this problem? So actually this question doesn't make sense unless we have length L. I thought they were both length. R. But yet, Delete Gaming, can you confirm that this is what the question should say? Because I don't want to solve the wrong question. Actually, does this make sense? For the minimum moment of inertia, L and R should both be 0, or close to 0. So I don't know that this makes sense either. But, like, this is a lowercase l? This is supposed to be an uppercase I? But I don't know what that means, to be honest. See, Delete Gaming, I need to hear from you. I don't understand what the question is asking us. And until I hear back, I'm just going to go back to doing this. Okay, so, well, I did have a breakthrough with the branch cut thing, at least. Where I finally understood why that... why this choice of ranges for theta 1 and theta 2 corresponds with this branch cut here. And so then they say what the other case is, right? Where do they say that? Theta 1, so make theta 2, which goes with A from minus pi to pi. W, surely just sub in for M and V. And find DIDL and set it to 0? I don't know what V is here. Well, okay, so what's the volume of a cylinder? It's pi r squared h. Is there a constant in front? I don't think so. Volume of cylinder. Okay, yeah. Um, and then you also want, if I'm something for M, I assume you want to bring density into the picture. Uh, okay, so you're saying to do this because rho and volume are both constants here? So I guess the so one of the issues here is that as Delete Gaming originally posted it, the length and radius are both R. Um, and I assume it's a typo, but they haven't said anything else in chat. I feel like they just put the question in chat and left, from how it seems. So I assume they mean length L and radius R, but like that's why I just kind of left the question alone because it seems like there's a typo. But even then, I don't know, like, if it is length L. I don't know. Okay, if I just believe you from here and we get DI DL, set equal to 0. And then do we want to do the same thing but with R and then divide them maybe? Actually, I don't know that volume is a constant because the length depends on volume, right? I surely did something wrong. Or the volume depends on length. Rocky, I don't know, to be honest. I'm not sure. Yeah, Gov, if you can get anything that makes sense, like, let me know, but I think what I did, I don't feel like it makes sense, because I'm treating volume as a constant, but it's not necessarily a constant. Because we're changing the length, so it kind of shouldn't be. Uh, yeah, I mean, I ideally put an image in Discord. If you'd rather upload it to like an image website and post the link here, links are turned on in chat. Hey, Nikhil. Okay, thank you. No worries. Okay, so the complex analysis here is unrelated to the question we were just looking at. Wait, um, in the downtime when there aren't questions, I've been looking at branch cuts and just trying to learn more about them. So, the book that I'm reading is talking about this function, and I'm trying to figure out if you use these kind of local polar coordinates that they set up, why does the particular choice of theta 1 and theta 2 lead to the how the branch cuts look? And so I just had a breakthrough and figured it out for why this choice of theta 1 and theta 2 gives us this branch. And now I just want to confirm what the other case is, which is if you let one of them go from minus pi to pi, you get the branch cuts that go out to infinity. That's what I'm trying to figure out right now. So the angle around A is being measured from minus pi to pi. But I want to investigate both this circuit and this circuit, I think. Let's start with the circuit around A. So B measures this circuit, let's just say from here, starting from 0, starting from pi, B varies up to something and then comes back down to pi. Or, well, I guess down. It goes from pi closer to 0 and then back to pi. And then once it crosses branch cut, it smoothly goes from pi up to something and then comes back down to pi. So B isn't going to produce any discontinuities, but A is going to start measuring from 0. It goes up to pi, and then suddenly when it crosses the branch cut, it starts measuring from minus pi and goes back up to 0. And so if B is always measuring pi at that point there, approaching it from above, A will measure positive pi, which will give us 2 pi over 2 is just pi. Each side pi is negative 1. Oops, sorry for tapping my mic. And if we approach it from below, B is measuring pi, A is measuring negative pi, which gives us angle 0, which is positive. Okay. And so the reverse will be true for the other circuit then. Tyler, Uh, Yesterday I was out with family. I was pretty much out for like the entire day, so no, I wasn't able to stream. But I'm back now. I'll leave that there. Okay, actually, no, I do want to know what happens with the other circuit. Yeah, we went to county fair. You know, so I was visiting my sister and brother-in-law because they just had a kid, my nephew, like 2 months ago, and so I was there for him being born, and I wanted to go back to just see them again. And so my mom and I just like gave them a break and just like watched the kid for them for a while, and then after we went to the county fair, but they live like 2 hours away, so it's a county fair for a county that I don't live in. I'd never even been to my own county fair though. I don't think. Don the Family Man. I mean that I haven't seen them in 2 months, so I feel like it's not that Family Man. It's kind of weird because like my sister and I even joke that like we consider ourselves like really close, but we hardly talk to each other. Like we do not like text or call unless like something is happening. I don't know. It's just kind of weird like that. Uh, so for this other circuit around B, A isn't going to give us any discontinuities. A is fine. B will give the discontinuity if we approach at this point from above versus below. Because A is measuring 0, and B will measure either 0 or 2 pi, and that makes a difference. Okay. Oh my god. I finally feel like I understand the branch cuts for this basic function. It's not basic, but it's like the small step up from basic. See with your cousins and such, see them on holidays, don't talk the rest of the year, but are there when needed. Yeah. That emote is so extra. Yeah, so that's all like pretty much my entire extended family is. Always there when needed. I guess some of them talk to each other more than others, I guess. They're better about keeping in touch. Um but yeah. Mulik, right there in the YouTube chat works or in Discord. Hey Jasu. Hope you're doing well. Okay, so yeah, now this function shouldn't be that big of a step up now. Oops. You're the world's worst in my mind. So if they want to talk fake calls, so text me. I won't bother them by reaching out first. Yes, it's such a terrible mentality, but I felt that too. I do my best to try and break that and just like be the first one to talk. sometimes, but I'm also kind of just like introverted in general, so it doesn't always like occur to me either. What book is this? I can show it. It's not an amazing book, but it's good enough. You heard back from the journal, kind of. Peer reviews are in. They sent me an email querying if I'm supposed to be the sole author, and now it's gone back out for peer review again. That seems weird. The only thing that changed is a clarification on who the authors are, just you. And they have to review it a second time? Well, look, you can send it in math discussion or math homework help, whichever one is easier. Probably just like math discussion is the easiest one. Oh, what is this? Ugh. Really can't believe it's just you. Apparently. I assume the task here is to just find the sum. FA. How does this equation make us better at repo? This equation is the key to not bumping the harp against every wall in the game. If we can solve this equation, we'll never lose money on harps again. Please solve, yeah. So I don't know if I can. So this looks like a kind of a crazy one. The first thing I would try is a product to sum. Even like keep it from falling in holes. Yeah. I'll try and find that equation right after. Oh, Gov. I see you're posting your work. Thank you for that. With huge and solvable. Oh, really? Okay, so product sum maybe isn't a good idea. And yeah, Jesse, you're right. It is just an offset. It's not necessarily a clean offset. I don't quite know how to think about it. Okay, this one with the signs might take me a minute. Let's go through the work that Gov just posted, just so we can show it on stream in case the person who asked the question ever comes back, doesn't just drop a question and run. And then I'll think more about this problem with the sum of signs, or yeah, the sum of signs, I guess. It looks like, I don't know if it's actually a competition problem, but it looks like something competition would ask. And so my warning is that I don't know competition math, and please don't ask me competition questions because I don't enjoy them. This is the work that Gov did for the moment of inertia problem. I just want to look through it quickly. I've done a question like that since first year in Tony Mechanics. Yeah, I hardly learned about rotational stuff in my classes. It's a pretty big weakness of mine. It's your 11th module question? Oh man. Okay, so you're saying r squared is rho v r squared. Wait, oh no, I'm sorry. You're saying m is rho v. I majored in applied math, minored in computer science. And so I just had to do like 2 semesters of calculus-based physics. One of them was mechanics, the other one was E&M. Neither class was very good, I don't think, though. Okay, so you substitute to get I in terms of just L. Theoretical physics and astrophysics. Oh, I'd love to do astrophysics. To use the labs as well. Okay. Jess was saying it is a clean offset for the sine question. Pi over 4 plus k pi h over 8. Okay. So then you find dI/dL. You get that. You set it equal to 0. You find that. L cubed is 3 over 2v over pi. I think that's what I got too, but I didn't know what to do with it. Then you substitute back. Oh my god. I thought substituting it back would just get something circular. That's probably what they wanted. Okay. Thank you, Gov, for posting that. So yeah, this is the stage here where I wasn't really sure like if that would actually help or not, but it actually does. Okay. That makes sense. Thanks, Gov. Okay. Nice. And so if the person oh my god. Is this question solvable by anyone on Earth? A question you're currently working on? I can take a look. Muluk has posted these 2 questions now. And I don't know if I can do either of them. Okay, so we're saying no product to sum. I'm not going to read the second one yet. The offset, it is just pi over 6, right? I can see that, Jasu. I guess when I said clean, I meant like pi over 2 or pi or something. Like, yeah, product to sum is gross. Would it be a good idea to do a difference identity? Like treat that as a unit and do a difference identity for that minus that? What's the difference identity for sine? Sine, cosine, minus. Okay. Let's just see how that looks. communicate. Oh, you're right. I could do pi over 4 minus pi over 6. Hey again, Krim. I don't know if you know any quantum mechanics, but when you put in is just lineage. Is this JE advanced? This one is from Mulik. There's also this one that they put in too, which looks equally as insane. Oh, it's Olympiad? Yeah, I'm sorry, Mulik. That's even worse. I don't want to do either of these. I'm sorry. I just literally I don't know how to do these, and I've spent so much time on these types of questions just not knowing the tricks or anything. I'm kind of done with them. I'm sorry, Mulik, but I just can't do those types of questions. So much trauma. You need therapy to fix your JE prep or your JE trauma. JE to me looks boring and hard. I never gain any insight from the questions that they ask, and they always rely on the most vague ideas that no one's ever heard of. Actually, we're just looking at these two problems. I'm moving on from them though, because I don't want to do these. Gov posted a quantum mechanics that's just linear algebra, apparently. Yeah, sure. Like I'm gonna see if I'm gonna just like look at this one first, but you can be right after if you want. This is a lot of notation that I don't know. I've never done any quantum mechanics. Uh, I assume H bar is just that constant H bar. H hat. I don't. Is that a matrix? Yeah, Janie, I'm not integrating that. H hat is the Hamiltonian operator. I have no clue what that is. Take the adjoint in part A. Adjoint is Hermitian conjugate. I learned what. Okay, wait. A Hermitian matrix is one where it's like the matrix, it's like symmetric, but like you conjugate it or something like that. I've seen a joint. I'm trying to remember what it is. I'm trying to dig in my memory. Maybe I should dig in my Google instead. That's probably a better idea. Complex conjugate transpose. Okay. I can get behind that. But like the matrix comes from Age of Hat, right? Because I don't see any matrix to do this with. uh Taylor expand 7. Is this not already Taylor expanded? How do you expand this more? Do you just take the conjugate then? Um, I'm, so like this is like a matrix. Like I'm still extremely confused. Like you're telling me I don't need matrices, but how do I do a matrix operation on something that's not a matrix? Like that's why I keep worrying about this. And so I assume this is like e to the power of a matrix, but like, and I know that you can define that with Taylor series. Yeah, I'm sorry. I'm just a little bit too confused by what all is happening here. Oh no, I'd never done bracket or anything with Hamiltonian whatevers. Like, Quantum mentioned a Papadoria. Yeah, I'm sorry, Gov. I would like to know this stuff. I've never even touched it though, so I'm very confused by what's happening. I think I can kind of tell sort of what this stuff means, but don't forget your bras. Yeah. Um, Hamil Eigenvalue equation for Hamiltonian. Let's see how that looks. Formal education institution to like teaching something at community college. I'm starting a master's in a few months. So as a student, I guess, yeah, it'd be cool to be a teacher. I like a community college, but I don't really have any plans for after. H hat is variable 7 to 9, it's obvious. You gotta go, Gov? All right. Sounds good. Yeah, I'm sorry. I don't really know. I sort of know the first thing about this, but I also don't know the first thing about this. Where I think the linear algebra concepts are familiar to me, but the context that we're using them in is completely foreign to me. Let's get back into teaching. I think it'd be cool. And yeah, Gov, feel free to post the solution. And yeah, Expert, if you want to post whatever problem you had, we can take a look. Have I taken physics? Yep. Ah. In my degree, I did just 2 semesters of physics. Mechanics and E&M. And then I've independently studied more advanced E&M and a little bit of general relativity and some more mechanics, I guess. Do I know the complete graph K5? I sure don't. What is that? Complete graph K5. Yeah, just like nodes and edges. Recommendations for financial mathematics and quantitative finance. No. Slim might know? Because he's done some financial math on his stream. I never read a financial math book though, so I'm not sure. Complete graph K5 has 5 nodes with every edge between 2 nodes. Oh, and it just looks like a pentagon with a star inside, I guess. Hail Satan! This math problem was brought to you by Satan. First, something easy while I type out the actual problem. How many edges are there? You can draw it in other ways? Okay. Well, you have... Okay, let's try and do this the good way, not just counting by hand. Each node has 4 edges, right? So presumably we have 20 edges. Am I overcounting? I'm overcounting. I'm double counting. It's probably... the first one has 4, the next one has 3 unique, then 2 unique. So it's probably 4 factorial. So 4 times 3 times 2, 24. 5 choose 2. That, oh, you know, I feel like I've seen that before. I don't remember why that is. Let's just count them the old-fashioned 1, 2, 3, 4, 5, 6, 7, 8, 9. I missed one. 1, 2, 3, 4, 5. Oh, I missed that one. Okay, so 10. 5 for pentagon, 5 for star. That's a better way of thinking about it. N minus 1 over 2? That looks like Gauss's sum. That's probably also just 5 choose 2. Or n choose 2. Consider the distance between any 2 points. We can only travel along the edges. Okay. Looks like some edges cross, but you can't switch. Right, right. What's the maximum distance between 2 points if each edge is distance 1? Points can lie on edges. Or like, usually Canton graph theory, but so like I could have a point just like halfway through this edge here if I wanted. Oh, that's weird. Okay. Uh, so well, okay, if that happens, then will that count for half the distance? Yep. Okay. Can that be always worse than it being on the nodes? Maybe. Hail Satan. Yep. This problem brought to you by Satan. Actually, no. I feel like okay, if I choose, let's just say that point halfway, and let's just choose this node arbitrarily. Uh, wait. The maximum distance between 2 points if each edge is distance 1. So if I'm being obtuse and taking the worst path possible, 1, 2. I assume I can't retrace. I can't go to the same node twice or the same point twice. So otherwise I could do an infinite circuit. Uh, so 1, 2, 3 into half. But that I may as well just go to I may as well have said the point I was interested in is over there and get the full 4. Basically, interval 0 to 1 glued at the vertices. Okay. I've gotten 4. I don't know that's the most it can be yet, but well, I could say like 4.9999999. I could say that. 4 is too big. Oh wait, the longest quickest path? Or what's the actual question then? Oh, distance is shortest way. Okay. So what's the longest distance, assuming we always go the optimal or like the shortest path? Okay, okay. No worries. Okay, well, So it's called a geodesic. Oh, wow. I didn't realize the word geodesic will get used here. I'm a little bit scarred about geodesics from learning about differential geometry. Okay, so if I choose, say, that node and that node, well, I guess that's one. Wait, so every node is connected. So if I choose two nodes, it's always, the answer is always one. So if I choose like this point here and that point there, I can make it approach. If I choose this point here in that midpoint, I can make it approach 1.5. Chaotic Diamond, can I solve a physics problem for you? Don't you know way more physics than I do? If you want, you can post it, but like, if I remember right, you just know a lot more physics than I do. So the answer is probably I can't. But I studied differential geometry on my own while trying to learn about general relativity. Papador, we're trying to find 2 points with the longest distance between them, and you always take the optimal path. And you're allowed to, you don't have to choose a node. You can choose any point along the edges. I'm thinking of someone else. Oh, I am thinking of someone else. Okay. Yeah, sure. Go ahead and post your problem. It's not, you pointed it out. Oh, for, yeah. For what Jess was saying. Anjani is saying, on a triangle, 7 perimeters, the maximum distance possible. Perimeter divided by 2, I think. And I mean, you'll be up right after we talk about XFret's thing here. Can I get longer than 1.5? If I chose a point here, that's still 1.5. My 1.5 path is this. That's 1. No? Okay. In theory, this point is like very close. Well, I guess it doesn't matter. It could be all the way on the node. Pointed out one that. Oh, okay. Non-integral rational solution to x squared plus y squared is 5. Oh no. We start in the middle of an edge as well. I thought that was worse. Because if I started, say, here, I'm just getting a total distance of 1. But maybe I should choose a different second node. I don't know if a second node. Okay, what if I chose that or that? No, it's still 1.5. That? Oh, that seems like a good choice. This one right here. Bam. Bam. Okay, that's 2. Okay. Halfway point of lower left edge. Oh, and that would accomplish the same thing, Phobos. Yeah, I think. Okay, yeah, okay. Length 2 is the longest we can get, I think. How many geodesics, shortest paths does it take to cover the whole graph? Well, so there's 10 edges in total. Yeah, at least 5. That's the first thing I was gonna figure out. Um, but then we might need more to cover up any like little bits. Um, can I do it with 5? I guess let's find out. Okay, so if I draw the geodesic between these two things, where does that get me? There are multiple choices for the geodesic. I could have gone up from here also. Um, do I want these 2 points? Maybe I want these 2 points. This is such a waste just to get that edge. I don't know how else you would get it though. Okay, but that's 2. Three. 4. Oh, I don't think... I think I'm getting 6 with this choice. 5. 6. Wait, I mean, I think maybe I just did it bad. My first choice of geodesic was maybe 4? Yeah, it kind of did. Yeah. Um, but I think, yeah, I think I can see the pattern with being able to do it in 5. Yeah, that's 5. Okay. Now ponder if you were allowed to choose how long each edge was. Can you come up with something where it takes fewer geodesics to cover the whole thing? You were allowed to choose how long each edge was. Can I cover more of the graph of the geodesic? I guess it's like, I understand that's asking like playing around with the weights of the edges, like make that one weight 2 or something, or a half. And we're trying to get fewer geodesics to cover the whole thing. Okay, so can I just pick the optimal half my change yielding? Yeah. So like if I go back to choosing this point and this point, I would travel along this edge, but if this edge was suddenly, if it costs 5, then it will be better to take. Oh, I guess yeah, if one path was too big, then you would never go on that. It's hard to find the correct weighting? Yeah, sure, I guess. I'm probably not figuring out on natural. Choose one vertex, and every other vertex is a half distance away. So if I choose this vertex, a half, a half, a half, a half. There's a shortcut vertex that's a bit closer to everything. Okay, so now let's try and let's see what happens with this. Geodesic between these 2 points. Now we can get it with 4 geodesics. Okay. So there's going to be one of these things, like one of these pairs of points that we don't want to choose, I guess. But I'm with ones that are completely not on these 1/2s. It's the quickest between these 2 points. So could be, can we beat 2? 1/2. You found it via computer search, so you low-key cheated. You only did that because it was, you're basically convinced it didn't exist. 4 is also the lowest for K4, which has almost half the edges. Huh. I don't have to think about those 2 points I just chose. What about these 2 points? So can we do better than 2? We can travel along half of half, so a quarter, plus a half is 3/4, plus another half. That doesn't cover more ground. It's the unique weighting that works. Wow. Besides, you know, throwing out scaling, of course. You always start and stop halfway through an edge? Okay. Yeah, I was just wondering if always going to the middle edges is a bad strategy for this weighting. So I don't feel like I'm doing it any more efficiently. Like I'm not covering any more ground. You always cover the entirety of any short edges? Wait, so it like just from this dark green thing, does that cover just by doing this one dark green path? Does this also cover like the other portions here? Is that what you're saying? Oh, okay. Oh, I mean, or maybe I misunderstood what you said there. I think it's been like they're automatically covered just by doing that, but I don't think that's what you're saying. You can extend the short edge side, but not the long. Oh. Oh. So I could have taken, say, that one and brought it all the way over here. Because 1 plus a quarter versus half, half. Hmm. Did I choose the wrong one? Because the geodesic is going down through here now. You got a seductive Heinz ketchup ad? You don't know how to feel about it? I say just keep an open mind. There's 1.5. Oh, okay, yeah. It's an equal. Okay, yeah. Catch up with the times, yeah. So I was thinking that like this path down here, it's equally as good though, I guess. So we could choose the one that covers more distance, I guess. Okay. Um, and so presumably we should do the same on the other side. So we should connect here and there? Question mark? No. Wait, this should be able to be reflected, but and strictly the sun in case of the stupids. There? That one? That'd be 1.5. Okay, yeah. So then we take that note and then we go like this. There we go. Okay. Well, we still have 3 more edges to get. Gotta think bigger. You had the stupids all morning. Oh, right. You did say I can always start and stop at an edge. So should I could go here or halfway? Hmm. Then I could do kind of like the reflection of that path. Where I go here, 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 here. It is a long geodesic, yeah. Okay, and then we only have two remaining edges to cover, and that we can do, or like, when I say remaining edges, I mean outside edges, and that we can do with normal, the pattern we were using the last time. Actually, yeah, we have four edges total. I want to choose that point and that point, maybe? Because then I can do the reflection of that path too. Yeah, there we go. Whew. Four geodesics K5 covered. That's I've never heard of a metric graph where you can stop like halfway through. Kind of wild. Oh, this is a unique example and surprisingly small. My computer program found it had been running overnight. Wow, it took like all night to find it. You got 2/3 of the way through all the examples and you went to bed. Notebook was on case 52,000 out of 5,300 or 53,000. Wow, it's a crazy amount of computation to find this. You almost stopped it early. Oh no. Wow, yeah, this is a cool problem, expert. Thanks for showing it to us all. Almost done. Where the chance this thing existed? It is weird that it exists. It exists and is unique. That is kind of wild. Like finding the weighting would be the really. Well, so wait, was your program messing with different weights, or did it use these weights and just try to find the path? Yes. Okay. Yeah. I was playing with the different weights. Okay. Huh. Get over all possible sets of 5 paths. Oh yeah, I guess you always have to start halfway through each edge, so that does narrow down the number of cases to check, I guess. You probably still want to throw some of those cases out. You don't? Okay. I just kind of assume that starting halfway through is always your best bet. I guess that doesn't have to be true. Oh, okay, okay. Yeah, I guess maybe there's a different weighting where it's better to start on nodes. Give a ton of other examples. Okay, yeah. I do need to get to chaotic diamonds question. I forgot that they asked something. Pull up front of the computer program. Okay, so for anyone who doesn't know Expert, he's like an OG of the stream. I feel like uh I think we met through like Factorio or something like that. But Expert's a cool person. Yeah, I think maybe you rated me one day or something like that, but yeah, I don't remember exactly. Something is cool looking. Oh yeah, I bet you could get some cool looking pictures with that. Thanks for your patience, Chaotic Diamond. Let's see if we can figure this out. A 200 Newton child. Okay, how heavy is that kid? 20 kilos, which is like 40 something pounds. Okay, that's reasonable amount for a child. Sitting on a playground swing is being pushed by her father. And the rope makes an angle of 27 degrees to the vertical. What is the force exerted by her father? What is the tension in the rope T? Wait, what? Is the father following her as she's swinging? Or is this the top of the arc? I think we're just supposed to assume the father is following her through the swing. It assumes the father is holding her there. That, okay, yeah, that makes more sense. Yeah, okay, if the child's at rest here and the father is holding her there, that's not very clear to me from the question, but I think that's what it has to be. At least this sounds like it's like a statics problem, I guess, where nothing's actually moving right now. And yeah, it's children are never at rest in general, and while they're swinging, yeah. It is meant to be a static okay, okay. Good to know. So the forces have to sum to 0. We're gonna need that fact. So downwards we have the weight of the kid. Is that a what letter is that? I'm just gonna call it G because I can't read it. It's a G. Okay, I'll say force of the father is what we want to find for the first part, and then the tension in the rope. It's not quite trying to scale, or the angle isn't quite right. If that angle is 27. If I want this angle here, that's also 27, right? Opposite interior angles or some geometry term like that. Z pattern? Oh yeah, that's a nice way of remembering that. Okay, so I guess what I would do here is, or how you usually do these problems is you sum up all the forces in the horizontal direction, set it equal to 0. Sum all the vertical forces, set it equal to 0. And usually that gets you what you want. There's some yard work happening. I'm sorry if there's background noise. No components? Well, I mean, the only thing we're gonna have to break up is the t, right? So we know that the force from the father, I guess they call it just F, minus the horizontal component of tension. Oh, I never learned force triangles. I don't know how they work. It would be a quicker way of doing this though, right? I'm gonna do it the slow way, an old-fashioned way. The force father exerting should be the horizontal component of the tension. So that's going to be, we're going to want sine of 27 to get this bit up here. Equals 0. And then vertically, tension is pointing up. This time we're going to take cosine of 27 to get the other component. Minus gravity is pointing down, which I'm just going to plug in the 200 newtons. Equals 0. We can try and figure out the force triangle. So I think it would be a quicker way of doing this than what I'm doing here. That's kind of funny. We can figure out what the tension is immediately, but that's the second thing they asked. I guess let's find the tension and then we'll find F. So the tension is going to be 200 over cosine of 27, oops, degrees. That's work for a calculator. $224. Yeah, that makes sense. 224.5, since we have one significant figure, and significant figures are the worst. 224.5, I said? Yeah. And if we know that for the tension, then we plug it in up here to find F. So just add this bit to the other side and then plug it into a calculator. You know, I can kind of see from this math how the triangles should look, I think. 101.9. So that's how I would do it. This way it's a bit more like generally applicable. I think the force triangle only works in certain cases. These are physics equations. Nobody's here. These are both from F equals ma. I don't know what else you would want. I think you basically take these three arrows and make a right triangle out of them. Hopefully Felix will correct me if I'm wrong here, but if we have the tension there, the gravity would go here pointing down. That angle is 27 degrees. And then F would be going that way. And presumably, you know that this side is 200. So with the right triangle, you just need to know a side length and another angle, and then trig will get you everything else. So theoretically, cosine of 27 degrees is equal to adjacent 200 over tension hypotenuse. And that would get you the same answer. Put a picture in Discord. They don't have to form a right triangle either? Oh, I didn't know that. Three forces in equilibrium must form a closed triangle. Oh, nice. Yeah, I was never taught this way, so I don't know exactly, like, I don't know exactly like where it's used for, but that's good to know. So yeah, chaotic diamond. I hope that makes sense. I guess you can use this anytime you have three forces in equilibrium. And don't make my mistake of assuming it's always a right triangle. We only had a right triangle here because there's a right angle there. Yeah. Triangle's just normal trig. Uh, oh yeah, so like the notes that like these notes here that Femox posted are just in the Discord. If you want the notes that I wrote, they can take a screenshot of them here if you want, or I can post one if that's easier for you. You know, I just remember I got you mixed up with chaotic dude, who does know a lot of physics. I just remembered his actual name now. But yeah, I did it kind of like the general way of solving force problems, just with using F equals ma. Alti physics is good stuff. Well, some types of physics at least. No worries. Thank you for the question. Ooh, that gets 3 hearts from Fembox. I like this like Fembox rating system because I feel like usually you just put like 1 heart for most subjects. I know. I still love the E and M that we were learning. So far, that's been my favorite thing. How do you subtract hearts? Gotta like delete the message. Ugh. Minus heart, minus heart, minus heart. Um. So yeah, unless someone else has a question, I might go back to doing complex analysis stuff. Or if anyone has something I want to like talk about. Just looking through the Discord to make sure I didn't miss a problem. I wouldn't say like geometry. We can take a look at it because there are people around who like geometry. So if nothing else, we can put the question up on screen for their sake, and I'll see if I can figure anything out about it too. But Uh, let's see. Let the double tick marks be V, the single tick marks be U. The expression you wrote is kind of messy. Oh, okay, so you have a different thing with... This feels in some way related to your graph theory thing that we just looked at, but... Just write U. I can cross it out. Single tick mark, we're going to say U. Double tick mark, we're going to say is V. And you want to find X? Been doing ACT math prep all summer with your eldest spawn. Kids gonna be so ready for algebra 2. Hell yeah, Alti. I never looked at like any ACT questions. I did the SAT, and honestly, like they seemed mostly like trick questions. Like the math involved wasn't too hard, but you had to be really careful with the wording. The program I'm using is called Journal++. If I'm collaborating, I use Excalidraw.com. A lot of people like on Windows, Microsoft OneNote. I never tried it for myself. But that's another option to consider too. I think it's free. Or this is a version of it that is free. Square root 2k is 2b. Okay. Is it root 2b? No, it's 2b. 2v or not 2v? Samsung Notes or Notability? I never heard of either of those. I was going with Journal++ because it's open source and free. As I think it's open source. Okay, so the first thing I was trying to think through is if the information we have here actually does like uniquely determine X, and it should, because we have this length down here. We don't have the measures of any angles, which is unfortunate because I'd love to just fall back on trig and not actually do geometry. We do have a bunch of isosceles triangles. So like this triangle here and that triangle there are the same thing. Trig bashing, but it's super ugly. Okay. I feel like we would need to draw... I mean, wait, is this line here supposed to be parallel to this line? Because what I wanted to do was draw like this line down here. Oh yeah, they probably have to be from how it's constructed. I don't know if we're gonna need it, but I just kind of wanted to make a rectangle down here. Maybe I'll redraw this. Actually, you just realized how to do it? Oh, really? See if I can do it? Okay. I should didn't know the answer was. Okay. I don't know what I wanted to investigate was just making a rectangle like that. Just feel like there's a bit more to work with. I feel like there should be some type of I was hoping we can figure out that like this right triangle right here is isosceles. It's not, if it is, that's not easy to justify though. Or I thought that like these two angles being the same would be enough to do it, but they don't do it immediately for us. Or do they? If this angle and this angle are the same, no. I don't think it has to be isosceles. The long horizontal is 2v, so half of it is v. False alarming method did not work. Okay. Gives you another isosceles triangle. Oh. You're saying we have an isosceles triangle V, not quite to scale, but like V, like an isosceles triangle there or something. Or like those two angles are the same. And also reflected across. Oh wait, so that, oh, you know what? If we do reflect it across, don't we have a third isosceles triangle? On the bottom with X? Right, yeah. Now, unfortunately, we can't really find the base of these isosceles triangles. It's not immediately. Very isosceles much equal very angles. Doge does math. Much wow. Try getting journal my M1 Mac. This thing is damaged. Spectre! The 27 months. Thank you so much, dude. Sometimes now older than you, kind of. Oh, with like months to years. I was gonna say, I don't think you're 26. Or time really has flown by if you're 26 at least. That's me that's saying it's damaged. Open another open source. I don't know, to be honest. I've hardly done research on these like drawing softwares. There should be, I feel like. You only notice now. That's fair. Either way, I appreciate it. Uh, so the problem is to basically, it looks less complicated than usual. It is just a regular geometry problem. The goal is to find x in terms of u and v. I said it backwards from how u and v. I've drawn on this a lot, but yeah, it is a hard geometry problem, but at least it's not like complex analysis like I've been doing where more people will recognize it or like what's happening. I was 23 less than 23 years ago. So you're less than 46. That's the same is true for me. It has a pretty wide range. So This I thought this triangle thing with the blue and light green is neat. I don't know what to do with it yet. I'm gonna erase it for now, just to potentially switch gears. Or like try another strategy. So like, if I draw this height here, do we have any shot at finding what that H is? More than 15 years ago. Okay, there we go. Now it's narrowed down. Not yet, at least. You know what, Spectre, if you want my advice, just stop aging. It's a mistake that too many people make. W advice. Thank you. I started to wonder, what if we also drew this thing here, but that's not necessarily H. It would only be H if X equals V. Starting, or you know, if you think about it, that could be taken as advice to die. That's true. I didn't think about it through that angle. I didn't mean it like that, but I guess that is kind of what that means. Think of starting with two triangles with both base V. Yeah, nobody's here. Sitting adjacent on that line length 2V. Allowing them both to rotate around the endpoints of that line. So their peaks touch in the middle. Oh. If you're saying the base, oh no. Huh, that's an interesting thought. Thinking about constructing this figure. So Fenvox is starting with this. It's not drawn to scale, but each of these are V. And then you basically grab this point and yank downwards, keeping these points on the outside fixed until they touch tips, basically. And so that's kind of funny because I think it would be true that would this length here be X then? Maybe not. The length to the top is V again. Really? Oh yeah, if you make the altitudes. Okay, yeah. I can see that. Your sense of humor reveals itself at just the right times. Oh hey! Spectre does have a good sense of humor. Another upside down triangle would slot in there perfectly. Don't fry bacon in the nude. That's a very practical fortune. No metaphors there. Maybe that's also a metaphor for something. Hey, wait, you know what? Does this construction work? It's 2D. You were about to? At like midnight? Or whatever it is for you, Spetchery? So wait, uh... mm, don't these have to start farther apart? Or like, if I did yank down to this point like I was imagining, are they intersecting? Maybe we don't need to worry about that? I don't know. Yeah, no, this is all, I could see how there's kind of like a perspective going on, but no, this is just 2D. Man, where's Jed to build this in GeoGebra when you need him? It feels like there should be some, like there should be something with ratios that we could work out here. I just feel like it's gonna be very tricky. Yeah, I don't know. I think I'm stuck. It's kind of a neat thing that Pinbox noticed with like constructing this. I'm not sure. I can't figure out how we can use that to our advantage though. Like I can't quite figure out what the similarities between the initial and final state should be. Basically, yeah, that's the only actual like measurement. We want to find x. In terms of u and v. V equals 0, x equals 0. True. Trivial solutions are my favorite. Problem solved. Okay, I don't have ideas for this problem. I think I've sat here and stared at it for a good enough amount of time for now, at least. The question is posted in Discord. Uh, and if anyone finds a solution, like let me know. I'm happy to like switch back to this problem, but I might move on to something else for now. So everything I'm trying in my head isn't quite working out. So, yeah. Um, so I guess maybe we're back to talking about branch points, branch cuts. Again, unless there's another question that pops up. And so I feel like I've just figured out the branch cuts for this function here. And I'm gonna look at the next case, which is if you add in a third factor. So I wonder if you allow these x's to be complex numbers, if you can get like diagonal branch cuts, if they're collinear. If they're not collinear, I don't know what you do. That's kind of interesting. Okay. I don't know if I want to bother investigating it, but I'm gonna guess if I had like, let's say x1 is there, removing the restriction that they have to be real. X2 is there, and let's say X3 is here. I wonder if you can get branch cuts that are... I don't know where this one would go. What direction that would point. Oh, really? Oh, that's cool. So just out of interest, like, what's the numerical answer that we're getting here? Oh, I guess it's a little bit hard to measure it with this. It's a lot smaller than V. Yeah, something like 0.22. Hmm. I guess here V is 1. and U we have to do trig or Pythagorean theorem. 0.5 so it's a random number. 1.25. It's interesting. So yeah, I wonder how you would combine those two numbers to get 0.22 or something around there. I would think it's just proportional, like just dividing. Well, I mean, what is that ratio about? Well, I don't know. There's U and V. I don't know. It could be like U plus V divided by something, or I don't know. That's actually a little bit too hard to. Yeah, I don't know. It's not clearly related. It's not like, 2V or something. Well, it definitely wouldn't be 2V, but like V over 2. Hey, Dr. L. If only that's all the problem was. I'll copy that Desmos link by the Discord. Or into the Discord too. Hmm. $10. He might still be here. He tends to go into lurk mode when he's like working on something. He might have also had to like get up for a minute. I don't know. If he pops back up in chat, we can show him though. Okay, I don't know what you do with that like other branch point there. It's probably not the most important thing to investigate with this. So I should understand the simpler case of them all being real numbers first. So for the case, they're saying we're measuring all the angles between 0 and 2 pi. Alti, I don't think it's constrained. Isn't U changing though? We're holding U fixed. Is this the same length as this? It looks shorter. Oh, this is something that Alti just posted. It's hard to tell, like, are these equal signs areas? I it should be constrained if like this length is fixed, because it looks like it's changing from one image to the other. But what we wanted to show you is XFret made the thing that you said. In Desmos. You set U to be 5, you didn't fix V. It looks like it was 5 in both cases. Vice versa? Okay. Oh, but I think they're both supposed to be fixed though. Like either way. They're both like given quantities. Yeah, same. Fembox. I bet GeoGebra you could like make this and like just measure it too more exactly. I just don't know how to use GeoGebra. I mean, do I though? I mean, it wouldn't do it arbitrarily. We could do it for like a certain case. Yeah, I don't know. Making GeoGebra might not be helpful. Doesn't change? Okay. It does depend on both. Okay. That's at least a hint. Would attaching a coordinate system help solve this? I guess it's basically, I guess you're basically gonna have to do trig there too, though. I wonder if is there like a simpler version of the problem we could solve? Like, what if U equaled V? Would that give us a quick answer? I'm not sure if it would, to be honest. Oh, Alti just did the case if U equals V. It goes all the way through. Interesting. Oh, this is CAD? I was wondering why I didn't recognize this. Hmm. For 3D printing, ooh, cool. That'd be a cool hobby to get into. Yeah, it's an interesting problem. Just not sure what to do with it. Okay, so with his branch cut business, um, how am I thinking about this again? So if I'm crossing somewhere here, let's just investigate. Um, Here we're always fine if we cross over that bit there, because the angle as measured from each of these 3 points is always varying continuously. If I cross through here, we get a problem if we circle around x1. We don't get problems from circling around x2, and we certainly don't get problems from circling around x3. If we circle around x2, wait, how does this working? If we circle around x2, where does the discontinuity happen? x1 is measuring, well, x1 is jumping from 0 to 2 pi. x2 isn't jumping, x3 isn't jumping. Well, oh, the angle we have to rotate the triangles through is arc cosine v over 2u minus arc cosine v over u. So the angle that rotated through would correspond with that angle there. and there. Can we find that in the initial state? I guess not. How are you getting that? Arc cosine v over u. I guess arc cosine v over u is probably coming from like this right triangle up here. Yeah. So that's the angle we're subtracting out. And so then presumably the entire angle is arc cosine v over 2u. Hey, Xerxes. In the unrotated state, because of the bottom left angle is v over 2 over u. Oh, you're looking here. Okay, yeah. I agree with that. So we've managed to fix those two angles there. That's probably the hard part done. How do we get to x now? We can probably just make this perpendicular here. Solve for this side here. And do 2v minus 2 of that. Yeah, I think that's pretty much the problem. $10. Um, okay, so we have, oops. Right triangle, hypotenuse V, angle theta. We want adjacent. Cosine theta is equal to, I guess we'll call it y. So then x is equal to 2v, oops, minus 2v cosine theta. And we probably simplified that too, because it's going to be cosine of arc cosine. And we can use a different identity. I kind of want to switch this to white. Um, okay, let me just look up the formula. I think it's cosine cosine plus sine sine. It sure is. I'm not going to write out every last step here. V over 2u times V over u plus okay, and now I guess we make right triangles. So arc cosine adjacent over hypotenuse. Oops. Pythagorean theorem. Let's make the other right triangle while we're at it. Yeah, it's gonna get messy. Why would it be clean though? Then I guess we can get a common denominator just to, I mean, they're not really gonna group. But let's get it anyway. Maybe they group. Hope isn't lost yet. No, they don't group. Meh. No, they don't group. Oh, did you get this with trig? I guess we use trig here too, but not that much of it. You think it's not right? No. I think what Fenbox did was right. So maybe I made an algebra mistake. I mean, I don't know why it will be clean. Hey, Mayor Sadag? You can cancel the twos. V1 minus V squared over 2. I don't know if that's the exact same. I don't know. What for the example that we did in Desmos. Oh, you assumed U was 1. Okay. Like, I just want to plug something in for U and V here, just see what answer it gets. How's Wolfram Alpha's dark mode? Does it have a dark mode? Oh good, it doesn't hurt my eyes. We can use dark mode. Oh yeah, true, Alti. So I'll say, what comes first? U? Okay, yeah, X is U, because I don't think, does Wolfram Alpha like U and V. Let me. U equals 1, V equals 2. 3? Okay, so it does work. V squared plus U square root 4 U squared minus V squared plus 2U U squared minus V squared over U squared. What do we do in decimals? V is a half. Oh yeah, U was something weird. What example was Alti doing? Well, yeah, I'll just send 1 and 2. What does this get? -4. That's not ideal. Did I give it an impossible situation, maybe? So I'm saying U is 4, V is 2. 25 over 2 plus root 15. 12 and a half plus 3 point something. That's way bigger than V. That's not reasonable. Okay, well, let me... What numbers did Alti? Alti used... U is 7, V is 2. I don't know what that number is. 29. That's not reasonable. I probably made an algebra mistake. Then Lux, let me type in your answer. Oh, it doesn't save dark mode? Bruh. -4 is a great number. It's the only number you can multiply by -1/4 to get 1. 7 and 2. Excuse me. Oh, it's getting messed up with this bracket. Negative number. Did I... Was there a mistake in the parentheses? That Femlux, should it look like this? You know, well, we could plug in U and V from like... I could give Wolfram Alpha this answer here and not worry about the messy algebra. It's like what you got. Okay. Yeah, I assume there may be a typo in there. Or something that went wrong in there. 2v minus 2v arc, or nope. Times cosine, arc cosine. Just let Wolfram Alpha deal with this simplification. Oh. That's not ideal. Imaginary number. Roughly, you're annoying me. Your answer works? Alright. Am I switching my U and V somehow? That's at least... Nope. Wait, what? That's a negative number. Okay, I don't know. You have your answer? Okay. Finds x over 2 because it's easier. Okay. V over 2u. Thank you, Fembox. .04. That's at least an answer. I don't know if it's reasonable. Proof by zooming in and checking it worked. Scale up and back down. How many numbers are there? In the original problem, we just have U and V. I don't know if that's what you mean, Dr. L. X over 2 is about... This is x over 2 here. Okay. Hmm. Is there a way to like just reset the view? I don't know. I think xfret got this expression here for x over 2, and it seems to work. The home button? Oh. Ah, that's smart. So the claim is that if you double this number here, that is that distance down there. And that seems about right. No, the formula I had, I don't know why it was off, but it does seem off. The one number where it matches to the 10th. Yeah, maybe. This number V was 0.5. H or U was square root 0.5 squared. Wait, shouldn't V should be 1? One plus 1.5 squared. .14. It gets a different answer, yeah. Wait, U is square root 0.5? Oh wait, no, oh my god, I did it right, then I did it wrong. .25. We might agree, Fembox. We might have done it right. I just don't know how to enter in formulas to Wolfram. 0.12869. 25738, 25738. Okay, yeah. Fembox, I think your idea works. Oh, you can click on that to copy it? Oh, okay. Nice. What a problem. Wow. That's pretty awesome. So I don't know how you figured to expert, but like how Upinbox at least was able to figure out from the like the angle that it gets rotated through. You did it the same way? Okay, okay. They confirm the better since they're only algebraic formulas. You never use arc cosine? I mean, I tried to simplify it down to not use any trig, but I evidently did something wrong. Arc cosine is evil? It is a little evil, yeah. You need trig. Cosine is... Oh, you just don't like arc cosine. Yeah, I was just getting confused with... I took the arc tangent of something the other day, and I cannot for life of me figure out how to get it into quadrant 2. Arc cosine is evil, angles don't exist. Wildburger? I don't think I've heard of Wildburger. Did he like topology or something? Oh, he has a YouTube channel. Oh, that sucks. Looks like a cool channel. He's crazy? Oh, with his thing with angles? Okay, okay. Arc cosine x equals tangent x on the domain -1 to 1? Does it? I can't imagine that's true. Ultra finitist? I have not heard that term before. No, that's definitely not true. Maybe you could like translate it around a little bit. Oh, no. Even if you translate it, it's not quite. F of f inverse of x equals x. Chain rule, Pythagorean theorem, voila. Oh, does that work? I think I've seen that way of doing it, Dr. L. Can always keep things certain sign of cosine signs, which never need to find the actual value of the angle. Usually we want a sine or cosine. That's true. That's fair, yeah. The inverse trig functions are pretty freaking unwieldy. Sambit, uh... I think we can calculate that directly. Please just post it once. I see you. So these are all unit circle values. Like, we can just plug things in here. Oh my god, Sambit. If you keep on posting, I'm just not going to do your question. Just got to keep in mind that the inverse trig functions break because invertible functions have to be one-to-one, and trig ain't about that. Right. Because you only need that to convert angles to lengths. Just want to avoid angles you don't need it. Yeah. Okay. Looks like Sambit stopped spamming their questions, so I'll actually do it. I would use a unit circle for this. I'll bring one up just to show you, because maybe you're new to it. So if you want to figure out what, say, like this cosine of 30 degrees is, what you do is you look in the unit circle for where 30 degrees is, and you just always take the x value for cosine. For sine, you take the y value. So cosine of 30 is going to be root 3 over 2. Then we have sine of 60 to deal with. So we go to 60 degrees, read off the y value. Same, are you even like listening? You just put like another question in chat. You're listening to the thank you, Dr. L. Okay, you know what, Sambit, I'm done with you. I'm not even through answering their one question before they start spamming the next one. Okay, just doing a quick check. Okay, there's no questions posted in the Discord. So I'm going to go back to looking at branch cuts, but I'm always happy to switch gears and do something else if someone wants to talk about anything. Should probably not go for a ton longer. I just realized we're at the 4-hour mark nearly. So we can still work a bit more on this stuff and see if we get something else in the meantime. So wait, I forgot where I was at with this. So I found there's an issue with circling around x1. The angle measured from x2 is fine. The angle measured from x3 is fine. The angle measured from x1 is what jumps if we approach from above or below right there. And then if we circle around x2, this is the weird part, because isn't... I know that the answer should be that the branch cut looks like this from when I read the book. So if I circle around x2, like what goes wrong? Oh, are we getting... It's getting like double offset for like approaching here versus here. You love branch cuts, Alti? I've been struggling with them. That's why it's been the theme of my stream today for the off time. So what's happening here? So as we approach from above, x1 and x2 are measuring something close to 0 degrees. x3 is measuring pi. So we just get pi over 2. But if we approach from below, x1 and x2 are measuring 2 pi. That's the trick. That's why we don't get issues here. And x3 is still measuring pi. So we get 5 pi over 2, which is just or I should think of it as maybe 2 pi plus pi over 2. And so it's just going to get sent to pi over 2. Okay, so that's why we don't get an issue for this part. That's the thing that I really wanted to figure out there, because it's like we get the same issue twice, which actually fixes it. Funny enough. Been less than 23 years, but more than 15 since you used them. I love this way of saying years. Remember liking them anyway? Yeah, it's really cool, especially with like vlogs, how you use the branch cuts to your advantage to be able to like count stuff with winding numbers. I thought that was a really neat way to take advantage of branch cuts rather than them being a thing that just like limits you. Okay, and then for the final thing, if we do a circuit around x3, the interesting bit happens around here. And so the same thing is still true with x1 and x2, both having the weird discontinuity and canceling each other out because of that. But then x3 introduces its own discontinuity. It's like an even odd thing. That's kind of funny. And that matches up really well, because I imagine if we had 4 points instead of 3 points, we would just get like 2 finite lengths. But here we get 1 finite length, 1 infinite length. Okay. Well, I feel like I understand branch cuts with a square root function a hell of a lot better now. The book's explanation of them is just kind of terrible. They go into inverse cosine after that. I don't know if I want to go into inverse cosine, at least not right now. Maybe we'll wrap things up, because we are nearly at the 4-hour mark anyway. That feels like a good length for a stream. Yeah, let's just call it. So yeah, people who are here on YouTube, thanks for being here. We're back on YouTube on Saturday. So see you, YouTube.